Hello students, today we will discuss about galaxies. So what do you mean by galaxy? So galaxies are a group of billions and millions of stars, gas and dust which are held together by gravitational force. Okay? So we have seen that there are so many number of stars in the sky looking at you, isn't it? And what does this galaxy different from a constellation? We have also specified constellation also as a group of stars. So what makes this different is that galaxies are group of stars or gas and dust which are held together by gravitational force. So they are very close, or it could be very close to each other. But constellations are the group of stars that seems to be close by from a point of view from a observation from Earth. So as we look at the sky, we feel that some of the stars, because they are in the same direction, they seems to be close by. But they may not be the case. That may not be the case. Okay, so that is how a constellation is different from a galaxy, or how a galaxy is different from a constellation. So galaxies are a group of stars which are held together by gravitational force, and it may include gas as well as dust. Okay, so they are considered to be the fundamental part of the universe, or you can say cosmic engine. Why? Because it is where a star is born. How? It is the region where the gas will turn into stars and the star will finally end up as gas. So a cyclic process is going on in the galaxies. So a galaxy is considered to be a fundamental ecosystem of the universe, and it could be of different sizes. It may be small in size or large in size, or it can be giant in size. Okay, so the next, so they, as we have discussed, they might be in a different size as well as they might be in different shapes also. So classification of galaxy was done by Edwin Hubble way back in 1926, and he named such a classification, galactic classification, as tuning fork diagram, in which he has classified different galaxies into four classes. And which are they? Based on shape. So it is named as, classified as ellipticals, spirals, barred spirals, and irregulars. And they actually differ very little from each other. They are fairly very close to each other related to their sizes. So let us see what is the tuning fork diagram Hubble has given for explaining the shape of the galaxy. So here you can see that tuning fork, you would have seen, it is like it has a stem and a fork shape, a semicircular shape, which is called tuning fork. So the stem of the tuning fork is occupied by, or it is used to denote the elliptical galaxies. And so we can see that the basically you could have elliptical galaxy, and as it get flattened up, it will end up as a spherical one. And so you can divide it into spherical with arms and spherical with a bar in the center. That is how you are just splitting it up, branching it out. That's all. Okay, it doesn't mean that they will be occupying like this. It only means that the elliptical galaxies will be one kind, and you have intermediate between elliptical and the spherical one, spiral ones. And the spiral itself can be of two types. It could be just spiral, normal spiral, or ordinary spiral, as well as it could be a barred spiral, which means a bar will be lying across the center. Okay, so here you can see the first one, E0, it's like a circular one, then it gets flattened like into a disc shape, and a zero intermediate between elliptical and the spiral ones, and all the spiral ones has arms like things or gas, it could be. Okay, so here is the distinction. Okay, so here also you can clearly see the arms are closer to the nucleus for a normal spiral, while in the case of barred spiral, a bar will be running across the nucleus or the center portion, and the arms are like spread out nature, okay, compared to the normal spirals. So let us see each one of them. So elliptical galaxies, the shape could be from a spherical shape to a football shape. Okay, so you can consider it as from football shape to a rugby shape, rugby ball shaped. Can imagine rugby is more like an elliptical one, while the football is um, like almost like a spherical one. Okay, so it is designated as using the letter E, and a subclassification is also given to show how much elliptically it appear. Okay, so this subclassification is numbered using this formula, that is 10 into a minus b by a, where a is the semi-major axis. That is, if I draw let me take it. So if I represent a circle, hope this is circle. Okay, so in all the directions, if you take the radius, it would be having the same length. Okay, like the spokes of a cycle, in all of the direction they will have same size. But if I take the ellipse, it would be like this, like the border of your rim of your eyes, isn't it? So this be the center portion, and if I draw a line to the rim here, it would be shorter than if I draw a line to the or axis to the this particular point. Okay, so in different directions it has different values, isn't it? So what is the maximum? The maximum is along this one. Okay, so that axis is called major axis. Okay, so semi-major means half of this. So half of this is denoted as A. Okay, and the minimum will be like this, which is perpendicular to the major axis, and it is called minor axis. Okay, and the half of the minor axis will be denoted as B. Okay, so if I draw an ellipse again with center here, so this would constitute the semi major axis A, and this would constitute the semi minor axis, which is denoted by D. Okay, so you can calculate this n by 10 into a minus b by a. So if n is very much larger, then it implies the structure is more elliptical. Okay, so you could have case of an ellipsis circle. So once you flatten it up, it will end up as an elliptical one. So the more the value of an, the more elliptical one. Okay, so this would be denoted as E0. Spherical one, like a football, will be denoted as E0, and once it gets flattened up into a disc shape, you will denote that particular galaxy as E7. That is how it is numbered. So this elliptical galaxies doesn't have any arms or not, isn't it? Just a round thing. So which indicates that it has very little of gas or dust. Okay, So gas and dust is indicated in arms. If there are no arms for the elliptical galaxy, it implies that it has very little or no gas or dust at all, or we can say very minimum. Okay, and most of the stars will be of same color. They will be redder than sun, and mostly it would be older and cool stars will be there in the galaxy. And it is similar to the center bulge of a spiral galaxy. That a spiral galaxy would have, in addition to the centermost portion, it would have arms. Okay, like this. This is the case of spiral galaxy. So again, it would be having a centermost portion, right? So the elliptical galaxy would look exactly like the spherical one, except that it doesn't have any arms. That is how it differs from a spiral galaxy. Okay, so hope that is clear for you. And there is no particular axis of rotation. It doesn't have any particular axis. Okay, and about 14% of the total galaxies we have detected belongs to the elliptical kind shape. Okay, so that is about elliptical galaxy. From the name itself, you can catch it up. They are elliptical in shape, so it would be from spherical to a elliptical, most elliptical one, and designated using E. So you can number it as E0 to E7, where E0 is for spherical one and E7 is the extreme case of elliptical nature. And because there are no arms present, it will have very little gas or dust, and most of the um, stars will be same in color, and they will be older and cooler stars. And about 14% of the galaxy so far detected is belongs to the elliptical galaxy. And as we have mentioned earlier, all the stars would be very few in number. Okay, so and hence elliptical galaxies are also very few in number. So this is how an elliptical galaxy would look like. You can see only a spherical one is present. Okay, and in the side-wise view, we can see the, here you can see the armed kind of spiral galaxies here, while this one represents a elliptical galaxy. So the next one is spiral galaxies. So spiral galaxies, as we mentioned earlier, it will be rich in gas. Why are they rich in gas? Because they have the how do we know? Because it has the arms. Okay, so arms is basically containing gas and, or indicative of gas and dust. And what are the parts of a spiral galaxy? First of all, it will have a flattened disk, okay, which consists of young stars, and two or more spiral arms might be there, and a central bulge which consists of all the stars, and a surrounding halo. Okay, and some would have a barred bulge, and they are fairly large in size, about 100 billion solar masses, and almost two-thirds of the galaxies, that is 70% of the galaxies, are spiral in nature. Okay, so what you have is, first of all, you have a central bulge. Okay, and after that you'll have a disc shape kind of thing, and after that, from the disc, arms will be there. It could be two or more arms would be there. Okay, so kind of a halo will also be there, like a cloud will be there surrounding the spherical one. Okay, so Hubble has again classified the spiral galaxies into two, depending upon how tightly these arms are to the nuclear part or the central part, as well as how large and bright their central regions are. So based on that, the spirals are divided into ordinary spirals, which will be denoted as just as S or SA, while barred spiral is denoted as SB, B for barred. Okay, so in ordinary spirals, um, the arms will originate directly from the nucleus, while in the barred spiral, as you can see, it is basically what? Yeah, a bar of material will be running through the nucleus, from which the arms will be emerging out. Okay, so that is visible in the next diagram, where you can see from this this is the picture of Andromeda galaxy, which is a closer one to Milky Way. So here you can see it has a spherical central bulge as well as the arms in the from the nucleus. So here also you can see a spiral one from which the arms are projected out. Okay, no two or more arms. While in the case of barred spiral galaxy, due to the density fluctuations or waves, it will organize the star center into a shape of a bar. So a bar shaped center will be there, and the arms will be originating from the ends of the bar rather than from the center. It will be arms will be originating from the ends of the bar. An example for barred spiral galaxies, Milky Way, which is our own galaxy, which is to which we belong, Milky Way. So it has an oval shaped bulge with a transverse bar from which ends the arms are projected out. So here you can see clearly, you can see there is a bulge and there is also a bar running across the bulge, from which end you are having the arms. So you can compare that with the Andromeda, where there is no bar, it is directly, the arms are starting directly from the center. Here you can see there is an elongated bar shape for the center region, and from whose end these arms are appearing. And the other kind is intermediate between elliptical and spiral is the lenticular galaxy, denoted as S0. So how it differs from spiral is that it doesn't have any arms. Usually the spirals are characterized with their presence of arms. While how it differs from elliptical? Because it has a bulge and a thin disk. Usually for an elliptical one, there won't be any, either it would be a bulge, totally bulged one, or a disc shaped one. While in this lenticular one, it has a bulge as well as a disc shape. Okay, it's like a magnifying glass lens in magnifying glass, and it doesn't have any excess gas or dust. Okay, so this is how a spiral galaxy will look like from its edge. You can see that there are no projections out, just a clean niche. Okay, so in the case of irregular galaxy, that is the last kind of galaxies, irregular galaxy. From the name itself, it is evident it doesn't have any particular shape as that of a spiral, elliptical, or a lenticular. It doesn't belong any to a symmetrical structure, randomly arranged ones. So it will have lots of gas, dust, and young stars, and it will have distorted shape, and about 3% of the total galaxies belongs to the irregular shape, and they are the smallest galaxies also. So here you can see there is no particular shape, they are just spread out. Okay, so the next so that ends our galactic classification. So what we have seen is that galaxies can be classified based on the shape. Based on shape, we have classified it into 4: elliptical, spiral. Spiral itself can be classified into spiral, normal spiral, or ordinary spiral, and barred spiral. and finally you have irregular shape, and in between spiral and elliptical you have lenticular galaxy. So now the next one is cluster. The next higher unit of the universe is the cluster. So the cluster is, as you know, cluster is a group of galaxies. Again, they are held together by gravity. Gravity കാരണം ഒരുമിച്ച് നിൽക്കുന്ന galaxies. Okay. So the group can be small, that is such as two galaxies ആയാലും orbiting each other forms a cluster, or it could be a larger one like rich a comma cluster of thousands of galaxies extending more than 10 million light years. Okay, that is how the distance scale is mentioned, and they are the clusters are the largest objects in the universe. Okay, so clusters are basically made up of two basic type of matters. One is called luminous matter. Luminous in the sense which make itself visible. It could be stars or hot gas. And other part of the cluster is dark matter, which is not visible to us, and hence the name dark matter, but its effect can be felt in the universe. Okay, but it cannot be seen. So dark matter does not shine on its own. So only if it produces light or it reflects light, we'll be able to see it. So it doesn't shine on its own, and the only way we know it exists is because of the effect on the luminous matter. How it gravitationally affect the luminous matter, by which we can know the presence of dark matter. And most of the luminous matter is in the form of hot gas. We think that most part of the galaxy is made up of stars, right? But that is not the case. Most part of the matter is in the form of hot gas rather than the stars. Okay, and they will be like very hot, and hence they will be radiating out some radiations, and the radiations would be in the form of X-rays. Okay, so we can make a direct measurement of luminous matter from X-ray observations of clusters or of galaxies. So this is an optical image of a cluster called Virgo, and this is the X-ray image of the same cluster. So here you can see lots of X-ray distribution is seen, but in this case there is nothing is seen. So what does it means? A very high amount of hot gas is surrounding the particular group of stars. Okay, so the optical image shows the visible galaxies in the cluster, while the X-rays the image display the hot gas between the galaxies. And the next point we are going to study is about our own galaxy, that is Milky Way. So like most galaxies, the Milky Way does not exist in isolation. It also forms a group. So along with Andromeda galaxy, it belongs to a group of galaxy or cloud, which is called large and small Magellanic clouds, and approximately 30 other smaller galaxies forms a group of galaxy which is named as local group, because those are the galaxies which are nearby to our own galaxy, and hence a name local group. So what do you think about this picture? How would we take a picture of a Milky Way? Because we are actually living in the Milky Way, and no one has gone beyond Sun or beyond Pluto. No other spacecraft has gone. So how would we able to take a picture of Milky Way? Okay, it is very difficult, right? But what we can do is that if you take a picture in all the directions, you can see that it shows a stretch across a night sky. Okay, so once as we look, so if you are in a row, if you're standing in a line, or if you are sitting in a class, imagine you are sitting in a class and just look around. So what you see, we can see people or students, classmates will be sitting along your directions, right? But can you see someone along the ceiling? No. Okay. So similarly, in the case of Milky Way, when we look around, it is seen that the stars are, or galaxy or stars, sorry, the stars are arranged along the same plane. Okay. Nothing is seen perpendicular to our observation. So, or our plane. So which means that it forms a stretch one. Okay, so that is shown here, and this is how, this is another galaxy which is similar to a Milky Way galaxy, which is NGC 821. So seen from another angle, our galaxy would look something like this. Okay, so Milky Way belongs to a barred spiral galaxy, which means a bar will be running across the central bulge, and even the bar has got a thin as well as a thick disk. Okay, thin disk of about 1 lakh light years or 30 kiloparsec approximately, and it also has a thick disk and a central bulge, and then a stellar halo, ഒരു പുക പോലെ ഇങ്ങനെ ചുറ്റിനും കാണാം, which is home to about 150 globular clusters containing the oldest non-stars. Okay, cluster of stars. So the sun is one of the hundreds of billions of stars present in the Milky Way, and it is situated in the thin disk. Okay, about 25,000 light years or 8 kiloparsec from the center of the galactic bulge. What does that mean? If the light from the sun to reach the galactic center, it would take how many years? 25,000 light years. That means if you think that you are going in the speed of light, then it would take 25,000 years for you to reach the center of the our galaxy Milky Way. So you can imagine how much distance we need to cover. അപ്പോഴേക്കും നമുക്ക് ജീവൻ ഉണ്ടാവോ? നമ്മൾ ഒരു 100 ഇയേഴ്സ് ആണ് ഒരു എക്സ്പെക്റ്റൻസി ഉണ്ടെങ്കിൽ 250 years നമ്മൾ about 250 times you are dead, right? അപ്പം അത്രയും സമയവും ഡിസ്റ്റൻസും എടുത്താൽ മാത്രമാണ് നമുക്ക് മിൽക്കി വേയുടെ ഹാഫ് പോർഷൻ അല്ലെങ്കിൽ കാൽ ഭാഗമെങ്കിലും കവർ ചെയ്യാൻ പറ്റുള്ളൂ. So you can imagine Milky Way is just one of galaxy in the universe. So you can imagine how much huge our universe is. Okay, so that is the beauty. And another point to be highlighted is that the sun is in the one of the spiral arm of the Milky Way, which is called Orion Spiralam. Okay, Orion Spiralam, and it is about 8 kiloparsec from the center of the galaxy, or it would take 25,000 light years distant from the center. Okay, so let us stop here. So so far we have discussed about galactic classification, and we have seen the term what is a cluster of galaxy, and we have seen what are the features of Milky Way, which is our own galaxy, or which is to which the sun belongs. Okay, so then thank you.